Hi, my name is Brad Modulewski, and this is my 310 final project. What I've made is a fully networked 3D game engine. So my three server-side computations for this project are one, fully networked game objects. As you can see here, I'm walking around and all the clients are updated on my position and rotation. The second one is I have an in-game chat where as you type, it updates on the other player's screens. It's kind of hard to see. I'll get up close to this guy. And if I just say, hello, friend, he can see it, yeah. And my third and final server-side computation is probably the most complex one, and it is the user can input what kind of texture they'd like the players to take on. So, for example, say we want something whimsical like fruit, apples, bananas, and peaches. You can submit it, and right now what's happening is this is going to the Elastic Beanstalk server, and then the Beanstalk server is calling a Lambda function to a Lambda function that calls the OpenAI DALL-E. Okay, here's the texture. As you can see, it takes our prompt, our apples, bananas, and peaches, and it applies it to every player on every client. And yeah, that's it. I'll get more into how I'll talk more about how it's done. So here's the diagram of my project's architecture. First, clients connect to the server. They access my personal domain. It's quackhouse.dev. And via AWS's Amplify, the static web page is served to them. So when the user receives the web client, the client connects to the Elastic Beanstalk server via a secure WebSocket. And this is the information highway that connects the clients to the server and synchronizes things like position, rotation, animations, and the text chat. And then the most complex part is the texture generation, which hits a bunch of APIs and Amazon features. So it starts out by the client typing in a prompt that they want the texture to be, and so something like ice here. Ice is sent to the Beanstalk server and the server calls a Lambda function generate texture where it has my OpenAI API key and calls DALL-E to generate a texture. This is what DALL-E returns, is a ice texture. And then from there, the Lambda function uploads it to S3. Once that happens, the process texture Lambda function is waiting, and an event is triggered when this is placed in the S3 bucket. And then from there, what happens is the process texture, it grabs this PNG and this one, and just using PIL, it uses Python to combine them into a texture like this, which, if you're not familiar with computer graphics, this is just like a texture where the UV maps. So these are the player's eyes, and this is the player's face. So that needs to be like generated on top of it to render correctly. So then from there, the process texture places it back in the S3 bucket, where, I guess I didn't mention this, the Elastic Beanstalk server is waiting. It's like constantly polling every few seconds to see if this texture is there. And then finally, when it gets there, it converts this into a base 64 string, and then it duplicates it, obviously, and sends it to each client. And then from there, my game engine code applies the texture to all the players. Yeah, so this is my project, and it took me a very long time This entire game engine was handmade, no libraries except WebGL. And yeah, I hope you enjoy it. Hopefully the server's still running when you're watching this video. Just go to quackhouse.dev and you can play it for yourself. And thank you so much. Whoa.